Welcome back, everyone. Well, today we've got a couple of samples to test out. These are from one of the locals up here. We got this rock, and we're going to test it for gold and silver. And then we've got some material that came from the riverbed. We're going to test this also for gold and silver. You know what we have to do. We have to start crushing ore. We're going to take some of this river sample and crush it up. Sorry, it seems I'm having an OMM. That's an old man moment. Can't remember what I was doing. Alrighty, well, we'll start crushing. Keep your fingers out of the way. Alright, once the initial crushing's done, we're going to sift it out. All we want is the fines. We don't want any hard lumpy stuff. The goal here is what they call mineral liberation. We want to make sure that we get all the minerals that we can exposed from the rock, so we crush up the rock as fine as we can. Alrighty, and we're going to put the uncrushed particles back into the crusher, or the mortar and pestle, as it is more commonly known, and crush it up some more. Now you'll notice that I'm not using Ramos's technique as featured in the last video. Ramos is from My Adventure, is his YouTube channel, and I don't want to get in trouble because that might be patented. So if you want to go back a video and watch him crush, you'll see how he does it. So here's our second sifting. So since we're going to be looking for silver and gold, we're going to first treat this with nitric acid. Any of the silver in the ore will be pulled out with nitric acid. Then afterwards, we will treat it with nitric acid and hydrochloric acid, known as aqua regia, which will pull out the gold. Okay, that should be enough. Now we'll weigh out about 100 grams of this sample. We're going to do 100 grams of each of the two samples just to be fair. So once I figure out how to put this scale together, we'll get some weighing going. It goes through a calibration process just to make sure that it's correct. Then I have to stand there and stare at it for a while to figure out what it's done. So we'll take this beaker, tare it to set the scale back to 0, and then we will add our crushed material in and get 100 grams. Yeah, that's about good. So we'll be treating 100 grams of each of the two samples. So this is the third water rinse that I'm doing. I want to make sure I get out all the silt and mud that I can, using a 10 milliliter turkey baster pipette to stir it with, just to make sure I can get a good stir. I don't know. We'll pour this off into our waste beaker and pour it off nice and slow so we don't wind up pouring our ore into our waste beaker. Grab our nitric acid. We'll add a little bit of distilled water into our beaker. You don't want to use chlorinated water like tap water. That will change the chemistry of your system and you will get odd results. Or you'll get silver chloride. So there's our first sample. We'll set that aside on the heater and let it cook for a while. Oh yeah, I forgot. I still have this big beaker of waste acid from my previous tests. And I was going to boil that down and test it, see if there's any gold or silver in it. So we'll put that aside and get to work on our next sample, which is this rock here. Kind of broken it up a little bit just to see if there's any visible gold inside. And here's the 100-gram sample from it. So we'll get this one started. Put some nitric acid and some water in here. Well, here's our ground up rock, and we're going to give it a water rinse. Rinsing out rock is not too critical because there's not a lot of silt in it. Hasn't been contaminated with ground dirt. We'll try and get out, the small floaty stuff that we don't really care about. Any of the stuff we care about is going to be heavy and it's going to settle to the bottom. But I'll pour it off into a clean beaker just in case I do make a mistake and dump out too much. You don't want to dump this stuff into a waste beaker with a lot of other material in it, because if you do accidentally dump out your ore sample, you're going to have to grind up another one. Last thing you want to do is contaminate your tests. You'll be chasing your tail for days. So since this material seems to be quite buoyant, I'm giving it a chance to settle before I pour off the water. I know, boring. But chemistry's boring sometimes. We'll get through this in just a moment. See, I told you we'd get through it. Thank God. Anyhow, I'm going to put some more water in here, base back our acid, so that we aren't using straight nitric acid. That can cause problems. So here goes our nitric. We're going to dilute it down to probably about 35-40%. Well, at least I've got one glove on. I'm half safe. I don't know why I don't have them both on. Put this up here to cook. Check on the other sample. It's starting to fizz away. We'll give it a stir. And we'll put on our other glove finally. I guess I'm just too busy to be safe, That's something you don't want to be in chemistry, is too busy to be safe. Now here's a little tip, if you forgive the pun. If you're going to be pouring stuff out of a beaker, let it settle at a slight angle. That way when you go to pour off, you're not rinsing stuff off the bottom so readily. It's pretty much congealed down in the corner. That way as you pour it off, it doesn't carry over as much material. Alright, after cooking for about a half an hour and getting it ready, we're going to filter it out now. I'm going to run it through our vacuum flask. And hopefully we'll get a nice clear yellow liquid coming through the filter. Now, since that solution should only contain silver, now we're going to mix in hydrochloric acid with nitric acid to make aqua regia to pull out our gold. And as before, we're going to base it back with some water. We don't need a real aggressive solution for this process. And now we will take our first sample and put it on the burner to start cooking for its gold recovery process. And the second sample is still cooking away for its silver recovery test, so we'll let that stay for a while. And here are the two samples. They are fizzing a little bit, showing that there is a chemical process going on, but we want them to be a little bit more aggressive or agitated, so we'll let it heat up a little bit more. About 175, 180 degrees Fahrenheit is good. In the meantime, our filter flask is barely dripping. May have to change the filter. We don't have much material and much solution through it. I think the filter papers I'm using are a bit too fine. They plug up easily, and that doesn't make things happy. But what we're going to do before we get all the solution through, so we're going to reach in with our turkey baster, grab a sample, and tip it to the side. Is really not a lot in there. This pipette isn't quite long enough to reach down into the bottom. Okay, I think I got enough. Okay, we're going to put a little bit of sample here in the spot tray. Then to test for the content of silver in nitric acid, you add a little bit of hydrochloric acid, and the chlorine will cause the silver to precipitate out as a white cloud in the form of silver chloride. Well, I don't see any white cloud developing, although I did notice a slight color change. There might be something in there. Give it a stir, and still no results. So it appears that sample 1 has no silver in it. And in the meantime, my filter seems to be a bit constipated. We're still pulling a vacuum on it, but it doesn't seem to be drawing anything. Pulling 15 inches of mercury or 40 inches of water column. We really don't want to go too much over that because it'll start causing the acids in the flask to boil out. So here's the samples that are cooking. The one in the back marked AU is the second sample. We're looking for silver in that, and this one is our aqua regia that we're hoping to find gold in. Okay, this filter is plugged up. I don't want to throw away the solution that's in there, so we're going to pour it off into a beaker and change the filter and then continue running it. That's how plugged up it is. Doesn't look like much, but it's enough to stop the process. We'll grab our tweezers here and pick the filter out. Sometimes it can be a little difficult getting out. There we go. We'll stuff that into our beaker full of filters. We'll do a mass processing on those filters someday and see if there's any precious metals stuck in there. Now I find these little filters are just as easy to put in by hand, wet, and they lay flat in the bottom so you don't have to fold them. Just make sure that they lay as flat as possible on the bottom. Hook up our vacuum line, flip on the switch and get the vacuum pump going, and we'll pour this solution back in and see how long it takes for this to finish filtering. Now here I let the pump run too long, and you can see the acid actually boiling in the bottom of the flask. I had to shut the pump off and let it mellow out. You don't want your acids boiling off because they'd wind up going into your pump and destroying your pump. Yeah, I got this way too low. It's 25 inches of mercury. That's what air conditioning people work in that range. 25 inches of mercury or lower. At that low of a pressure, it's going to boil off your acids, which will get drawn into your pump and ruin your pump. And a scratch in the glass or a chip, any defect, can cause an implosion. That's not something you want. So now to precipitate silver, we need to add our acid to copper, or add copper to our acid. And as the nitric acid takes the copper into solution, it will drop out the silver as a white, puffy, cottage cheesy looking stuff, which should then settle to the bottom of the beaker. I should be using a better beaker. This one's too short. If I get a reaction and it starts running away, it's going to overflow that beaker in a heartbeat. But I'm going to push the limits. I'm going to keep adding our materials to it. Now you see the solution is starting to turn green. That indicates that copper is going into solution. You might have to let this sit for a while. Sometimes the reaction is a little bit slow to get started. So we'll set this aside and see what happens in the next half hour or so. So we're back on sample 1. This is our Aqua Regia solution. It's been boiling now for about a half an hour. And we're going to take a spot sample of this and see if it shows any indication of gold. Now, as usual, I do 2 spot checks just to verify. Don't forget to denox. If you have excess nitric acid in your Aqua Regia, then your precipitate will go right back into solution and you'll never see it. Now I'm denoxing with sulfamic acid. So I'll put a few granulars of sulfamic acid in, and then I'll give it a stir with a glass rod I use a glass rod because I can feel if the grains are still present in the bottom. If they stay present, that means I have enough denoxing agent in there. If they disappear, they go away into solution, then I know I need to add more. Okay, we're adding our stannous chloride in. Stannous chloride is tin and hydrochloric acid. Very easily made at home. Give it a stir and see what happens. You can see it's pretty much going clear. That's an indication that there is no gold or other precious metals. It will also test for platinum and palladium. So if there is anything there, it's pretty sparse, probably not worth going after. Now, just to make sure my stannous chloride solution is good, I'm going to put a little bit of known gold containing solution in this one well, and we'll put in a drop of stannous chloride and see what the results are. Now keep in mind the gold content of this solution is very low, but you'll see dramatic results as soon as the stannous chloride hits it. And there it is. That changing color means happy times are coming. Alright, let's take a look at our silver here. Well, I see some fizzing coming off the copper, but I see no silver precipitating out. So there appears to be no silver in this solution either. Well, I think we can call sample 1 a bust. Shows negative for silver and for gold. Well, let's move on to number 2. Hopefully number 2 won't give us a number 2. I've got some of this in this test tube here. And we're going to add some hydrochloric acid to see what results we get. See if we get that white cloud that we need. So we'll put in our hydrochloric acid. We're getting a change into yellow. It's kind of odd, but I see no white cloudy precipitate. We'll let it sit for a little bit and see what we get. Don't be too rash or too quick to judge your experiment. Sometimes reactions take a while. We'll pull out the test tube and shake it around some. Still seems to be staying yellow, but I'm not seeing any silver precipitation in there. Let's see if we can get it to focus here. Oh, what the hell. Damn camera has myopia or something. Anyhow. Looks like sample number 2 is a bust on silver. But we'll give it a chance. We'll put it in a beaker with some copper and let it fizz away for a while, and hopefully we'll get a precipitate. Now we're getting some chemical reaction. You can see the small bubbles. Small bubbles indicate chemical reaction, and big bubbles indicate that you have gotten the solution to its boiling point. Since we're not heating it, it has to be a chemical reaction. This is starting to foam up a bit, so I put it into my spill tray just to avoid any spillage if it does boil over. Alright, we'll let this fizz away for a little bit and see what comes of it. In the meantime, we're going to move on to filtering it. So here's the balance of the solution of sample 2. We're going to filter this, see if we can get it clear. I'm using a bigger funnel this time. The other small funnel that I was using, I wound up having to change the paper in it about 3 times to get that sample through. Hopefully this one won't take so much tending to just to get it through the filter. Alright, let's pour it in. Remember, pour nice and slow. You don't want to stir up your heavies and your solids in the bottom and get them into the filter first. You want to get your fluids into the filter as soon as possible, and then get your heavies later towards the end. You don't want to plug your filter up right away. And this time I'm keeping a close eye on my vacuum gauge to make sure that I don't pull this solution into a deep vacuum and cause it to boil. Okay, got the solution in. Let it filter through. Well, let's take a look at our beaker. This is sample 2 silver test. Trying to precipitate the silver out of the solution. I really don't see much happening. I see some fizzing, I see copper going into solution, but I don't see any silver precipitating out. However, I do see a little bit more activity than I was hoping for. Yeah, it's going to boil over, so I'm going to pull the coil out, reduce the reaction surface, and wait for it to calm down some. It really doesn't look like it's going to cooperate. Yeah, as soon as I drop the coil back in, it takes off and wants to boil over. But as you see, the solution is a kind of a dark green. That means it's taken a lot of copper. And at this point I should have seen quite a bit of silver plating out, which I do not see. So I'd venture to say that sample number 2 is void of silver. But just to give it a fair chance, I transferred the solution into a larger beaker and put the copper coil back in, let it sit for a while. Still got the same results, no silver. Well, to speed things up, we went ahead and processed sample number 2 for gold. Boiled it in aqua regia for a while and filtered it. So here's our filtrate. And we will take a sample, put it in our spot tray, and see what we get. And of course, don't forget to denox. I'm going to throw some sulfamic acid in here and denox the solution. And we add a couple of drops of stannous chloride. Give it a stir and see what we get. Well, that looks like a big no to me. Our test solution has gone clear, which is an indication of no presence of platinum, palladium, or gold. Well, that's kind of depressing. I was really hoping to give my neighbor some good news. Well, in the meantime, he had given me a third sample, which I've sent out to a assayer, and we shall see what the results are on that. Until then, see ya!